Fun fact about calculus. One of the reasons that calculus was actually invented was so that people could solve problems involving real world scenarios, problems that involved the motion of different objects and how they, their speed and how they accelerate. And so one of the skills that is super key in calculus is understanding how to interpret rates of change. That's what we're going to look at in this part of the lesson. So let's take a couple notes. All right, we have this first statement. Shanice took a road trip. She drove for 3 hours and a total of 165 miles. Her average speed was 55 miles per hour. So this statement here represents an average rate of change. Right? If she drove for 3 hours and a total of 165 miles, if we divide 165 by 3, we get an average rate of change of 55 miles per hour. So this is a rate that happens over an interval of time. This is an average over a long interval of time. Let's contrast that with this second statement. At 4:32 p.m. exactly, Shanice looked at her speedometer and she realized she was going 72 miles per hour. So this statement here is quite a bit different from the first statement. This statement represents an instantaneous rate of change. An instantaneous rate of change. In calculus, you will often hear an instantaneous rate of change be referred to as a derivative. So rather than being the average rate of change over a longer period of time, this is at one singular moment. At exactly 4:32 p.m., this was her speed. In that instant, that was her speed. So this is a rate at a particular moment in time. So like I mentioned a couple of moments ago, one of our key skills in calculus is going to be able to interpret these rates of change, whether they are average rates of change or instantaneous rates of change. We're going to practice this in example number 2. Let's read it together. So example number 2 says, Brittany runs a successful YouTube channel. She tracks her views to know how to adjust her content. V of t, this function, represents her views each day since she started her YouTube channel. And our task here is that we want to interpret v prime of 3, which is equal to 582. So something that jumps out to me right away is that we are interpreting v prime. So this is the derivative function of v of t. Okay, so our interpretation is going to involve a couple of different things. First of all, I see that I want to find a v prime of 3. That 3 represents our instant in time, that one moment. So in this case, it's 3. Well, what is time measured in this question? Well, t is the number of days since she started her channel. So if we want v prime of 3, that would be 3 days after she started her channel. So that's how we'll start. 3 days after Brittany starts her channel. That's our sentence starter. So the next thing that we need to figure out is what V prime represents. Well, we know that V of t represents the number of views every day. And we know that V prime, the derivative, the instantaneous rate of change, tells us how that number of views is changing at that moment. So in this context, it would mean that the number of views is increasing, right? Because the derivative is positive. So the number of views is increasing. Well, it's increasing by how much? It's increasing by 582. So the number of views on her channel is increasing by 582. And last but not least, we need to figure out what the units are on that 582. Well, I know that V of t represents the number of views. So to figure out how the units for the derivative, I need to know how those views are changing over time. And in this question, time is measured in days. So our units would be 582 views per day. At that one specific moment in time, the rate of change of her number of views is 582 views per day. So the key idea here, to interpret a derivative in the context of a problem, we need to include first the time, or the particular instant, right? In this case, it was the 3 days after she started her channel. We need to include the rate of change, which is this part that says the number of views is increasing by 582. And then lastly, we need to have units on every single number that exists in this statement. So that would be our 3 days and our 582 views per day. We need to include time, rate of change, and our units. You are going to get an opportunity now to practice this key skill of interpreting a derivative and what it means in the context of a real-world problem, just like the creators of calculus did when they invented this wonderful subject. Go ahead and get started on practice set B.